Hello everyone, welcome to your first lesson in geometry, lesson 1-1, points, lines, and planes. Now, this lesson is pretty simple. It's really just going over some definitions that we use often in geometry, but that's exactly why it's so important, because these definitions within this lesson are used basically to describe everything else we're going to talk about in geometry. So it's really important that you understand what these definitions mean kind of in your own terms. I'm going to try to break it down for you, but at the end of the day, as long as you have an understanding of what each of these things mean and it makes sense to you, that's the most important thing here. So, the most basic figures in geometry are undefined terms, which cannot be defined by using other figures. Basically meaning they're most simple aspects of geometry. The undefined terms point, line, and plane are the building blocks of geometry. So let's first talk about a point. A point names a location and has no size. Otherwise, it has no dimensions. So it's just one specific location in space. And you might think of it as like an end of a line segment, or maybe the corner of a rectangle, or even the center point of a circle. Points are typically represented by just one capital letter. So in this case, this point is called point P. And it's important to name these points with letters so that way when we're talking about specific points, we know which one we're talking about. Now, a line is a straight path that has no thickness and extends both ways forever. So a line, whereas a point has zero dimensions, a line is one-dimensional. So you can think of it from going left to right, or you can think of it going up and down. It has one dimension. A lowercase letter, as you can see here, this little L, can be used to name a line. If you have a lowercase letter, typically it's going to be in script, next to the line, that could be used to name the line. So this could be called line L. Or more commonly, typically people will name a line using two of the points on the line. Now, just because we're naming this line XY or YX with, this is important, if it's a line that extends forever, when you name the line, you must put a double arrowed line above the name of the line. Now, just because we're calling it line XY, that doesn't mean X and Y are the only points on this line. There's infinite amounts of points on this line. X and Y just are two of them. But because those two points exist on the line, we're allowed to call the line XY or line YX. Now, a plane is a flat surface that has no thickness and extends forever. It's a two-dimensional surface, kind of like you can think of it as your laptop screen that you're probably watching this on. It has two dimensions, so your laptop screen has a width and it has a height. However, a plane in geometry isn't like your computer screen because it actually goes infinitely in both directions. Now, when you see a picture, like here's a plane, it doesn't look like it extends forever. This just looks like a parallelogram, right? But that's just because it's impossible on a two-dimensional surface that's tangible to draw something that goes on forever. But whenever you see any sort of plane shape, and again, it doesn't have to actually have four sides. You could see a triangle, and that's a plane as well. You could see a pentagon, and that's a plane as well. But typically when we talk about the idea of a plane, it should actually go in every direction infinitely. Now, the ways we name a plane is either using a capital letter, a script capital letter. So here, you see this script capital letter R, that's not a point, but it's in the plane. We can call this plane R. Or you can name a plane using 3 points on the plane. So A, B, and C are all points that exist on the plane, so I can call this plane A, B, C. Now, if I had another point on this plane, let's call it point D, I could call this plane either plane ABC, or I could call it plane ABD, or I could call it BD or BCD, or I can call it A, C, D. Really any combination of any 3 points that exist on the plane. Any 3 points that exist on the plane is an appropriate way to name a plane. Okay, so here's 2 more definitions for you. Points that lie on the same plane can be called collinear. So, looking at this diagram, I have point K, point L, point M, all on the exact same line. So I can say K, L, and M are collinear. However, N, this point over here, is not on the exact same line as K, L, and M. So I can say K and L are not collinear or non-collinear with N. However, that doesn't mean I couldn't say K and N themselves are collinear, because through really any 2 points I could draw a line. Typically when we use the words collinear or non-collinear, we're going to be talking about more than 2 points, because really if you have 2 points, you should be able to draw a line through them. Points that lie on the same plane are known as coplanar. Otherwise, they're non-coplanar. So even though N is non-collinear with K, L, and M, that doesn't mean I couldn't draw a plane. Let's call this plane KNL, where N is actually on the exact same 2-dimensional surface as K, L, and M. Then I would be able to say K, N, L, and M are all coplanar. And let's say I had a point that was underneath this 2-dimensional plane that I'm going to call Z. Then I would say Z is non-coplanar with K, L, M, and N because it's actually underneath the plane, not on the plane. Now, if we look at this example problem right here, the first question says name 4 coplanar points. So it wants me to name 4 points, 4 locations that are on the exact same plane. Well, when you look at this picture, how many planes are actually in this picture? The first plane should be pretty obvious: A, B, C, D. Now again, when you name a plane, you should really only name it with 3 points. So I really could call it just like A, B, C. But as you can see, D is on that exact same parallelogram. Now, the thing that seems to confuse people is if I actually look, forward at this object, A up to E down to B, that triangular shape is also a plane. Remember, a plane does not have to have a 4-sided shape. It just has to be a 2-dimensional surface. So A to E to B is actually a plane itself. And if I look sideways, B to E to C is itself a plane. A to E to D is itself a plane. I know that one's kind of hard to see. And then in the back we have D to E to C, which is another plane. Now, the only plane that I just named that has 4 points was A, B, C, D. Now again, that's a little misleading. It's not that it only has 4 points. Like, the plane has a ton of points, but the points that are showed to us is A, B, C, and D. So I am going to put that as my answer. A, B, C, and D are coplanar points because they're 4 points that lie on the same 2-dimensional surface, which is the bottom of that little pyramid shape. Then the next question just says, name 3 lines. Well, really you can name any combination of 2 points because, again, like I was saying, when we have any 2 points, you can draw a straight line through it. So I could say AB, I could say BC, I could say CE if I wanted to, I could say EA if I wanted to, but this would actually be wrong because I didn't actually name the lines, because remember, when you name a line, you have to put a double-sided arrow above the name of the line for the person reading to understand that you're talking about a line. And I know that, all this geometry stuff is new, and you might be saying, well, that's silly. I'm putting down, AB. They should know that's a line. But if you just put down AB, they don't know if you're talking about a line segment, array. They don't know if you want the measurement of the line. And again, these are all things we'll come across, but just trust me, if you want to name a line, you got to put the double headed arrow on the top. Now this next practice problem just says use the diagram to name two planes. And it looks pretty easy. Like they pointed out pretty well. Clearly this yellow one is its own plane, and this pink one is its own plane. But the nice thing about this question is it does point out the difference that, this pink plane right here, it has the 3 points pointed out to us, so we can name it using those 3 points. Whereas this yellow one, we have 4 points, which again, a plane only needs to be named using 3, so we can really just use any 3. Or it also has this capital letter that's not itself a point. So we can name it like that as well. Now, remember I was just harping on the fact that these lines, when we name them, we had to have a double headed arrow on the top. A plane has no such symbol. So when you're naming a plane, you really just want to write the word plane and then name the plane. So I'm going to name this pink one first, and I'm just going to call it plane CAB. And you might be saying, like, well, why didn't you call it ABC? It's because it doesn't really matter. As long as I have 3 points on the plane, I can write it in whatever order I want. Now, just to kind of prove a point with the next one, I'm going to call the next one plane R. Because again, once I have that little capital letter in there, I don't actually have to care about naming it using points. I can just name it using that capital letter. Now, if someone else went ahead and said, all right, I'm going to call it plane KLM instead, that's okay. These are both correct answers. There's a lot of ways you can be correct here. Okay, so now we're going to get into what I was kind of just talking about in that last slide, is that there are different types of lines, and we do name them using different symbols, which is why I was being very specific about putting that double-headed arrow on when we were naming the line. So the first one, probably the most simple one, definition is a segment, or most of the time we'd call it a line segment, is a piece of a line consisting of all the points between two exact points. So a line segment is really just a line that does actually end, and it ends at 2 endpoints. Now, when you name a line segment, you can't just pick any 2 points on that line to name it. You would want to use the actual letters that are the endpoints. So even if this had, point C in the middle of this, I wouldn't want to call this line segment AC, because that would effectively mean that I'm getting rid of this part between C and B. I'm going to call this AB or BA, because those are the endpoints of the line segment I am talking about. And now when I name a line segment, I don't want to put a double-headed arrow on top. I want to just put a line with no arrows, and that represents that it's a line segment instead of a line. Now, when I say, I kept saying the word endpoint. So an endpoint is a point at one end of a segment, or the starting point of an array. So again, a point is just a location. So when I'm talking about an endpoint, if I wanted to name an endpoint, I would just name it using a letter, because that's how we name points. And again, the endpoint is really just where something starts or where something ends. Array is also a part of a line, but it's a part of a line that starts at one endpoint, but then goes forever in another direction. So when you name a ray, so for example, this ray starts at R and goes infinitely to the right towards the point S, I would want to call that RS. And here the order matters. Up here, we called it AB or BA. In this instance, when we're talking about array, when you name array, you always want to name it using the endpoint. Whereas if I called this ray SR, that would be a different thing. That would mean I'm starting at S and going infinitely towards R. But that's not what's happening here. What's happening here is I'm starting at R and going towards S, so I gotta call it RS. And when we put the symbol above that, that's going to be a one-sided arrow. And yes, because I've seen this a lot, the one-sided arrow should always point to the right. Now, opposite rays are two rays that have a common endpoint. And most people look at this and they say, well, that's just a line. And, it's hard to argue with that because if I have two rays, so in this case I have ray EF, which is starting at E and going infinitely towards F. Then I have ray EG, that's starting at E and going infinitely towards G. And as you can see, F and G, when I go towards them, are in exact opposite directions. You are right. That does form one exact line. It's just a different way to kind of look at a line. We're breaking it into, all right, we're saying this point is the one end point, and, this point goes left and this point goes right, and those are two rays that form this line. All right, so here's some examples where we're going to do some drawing. And again, like throughout geometry, you're going to have to draw stuff like this in order to solve problems. So it is important to get used to being able to draw these things. So the first one's pretty easy. It just says draw a segment or line segment with endpoints M and N. So that's really easy. You're really just going to draw a line here, and you're going to make sure instead of arrows on both sides, you're going to draw endpoints. One of them is going to be M and one of them is going to be N. Now, could my N have been here and my M be here? Yeah, that's fine. That's totally okay. Now the next one says opposite rays with a common endpoint T. Now remember, what I was just talking about is that two opposite rays really wind up creating just one line. So if I want to draw this, I'm going to start by just putting a point T, and then I'm going to draw a line going through it, a line with two arrows. But in order for me to really call this opposite rays, I'm going to have T go through 2 points. So I'm going to have R on this end and S on this end, meaning I'm making two rays. One would be TR, starting at T going towards R, and the other one is going to be TS, starting at T going towards S. The last question here says draw and label a ray with endpoint M that contains N, which is kind of a weird way to say it, contains N. Well, if it has endpoint M and it contains N, really I'm drawing the ray M, N, something that starts at M and goes in the direction of N. So I'm just going to draw my point M, and I'm going towards N. And that's it. Pretty easy, right? So, as I pointed out in the beginning of the video, the reason that we want to learn about points, lines, and planes is so that we can really use them to point out observations about different shapes within our world. And these observations are typically called postulates and theorems. Now, a postulate, also called an axiom, is a statement that's really just accepted to be true because it's so obvious without proof. Whereas a theorem is something that needs to be proven. Now, a really famous theorem that you've probably heard of is Pythagorean theorem, which is super useful in geometry. However, it's a theorem. So it's not just accepted to be true. It's something that needs to be proven in order to be actually used. Whereas a postulate, again, a postulate is something like I could say to anyone and they're like, yeah, that makes sense. So if we look at these three postulates about points, lines, and planes, the first postulate says through any two points, there's exactly one line. Well, yeah, that makes sense. If I just have any 2 points, I can draw a line through those points. No problem, right? That makes a lot of sense. The next one says through any 3 non-collinear points, there's exactly one plane containing them. That also makes sense because, again, if through any 2 points we can draw a one-dimensional line, if I now have a third point that's not on that line, then I need to create a second dimension, which is in turn a plane. A plane has 2 dimensions. So I have the one dimension of the line going through 2 of the points, and once I add that third point in there, I gotta create a plane. Now the next one says 1-1-3, and again, these little numbers 1-1-1, 1 dash, that's just based off the specific textbook. Like these postulates are named based on like the chapters in the textbook, so you don't have to harp on what the names of these things are. Just as long as you understand the ideas of these, you're good. So this 1-1-3 says if 2 points lie in a plane, then the line containing those points lies on the plane as well. That makes sense, because if these 2 points are on the same plane, if I draw the line through those 2 points, well, that line has to also exist on the plane. Think about it. If you have a piece of paper, and we call that a plane, you draw 2 points on that piece of paper. As soon as you draw that line is also on your piece of paper. So these 2 examples, very simple, especially given the pictures they gave you. Example G says, name a line that passes through 2 points. Well, if G is aligning with this picture here, there's really only 2 points that even exist. And yeah, you can see that there's a line that passes through those 2 points. Like we were saying, any 2 points I can draw a line through. So as soon as I see that there's 2 points X and Y, I can say, my line is called XY. And because it's a line, I'm going to do the double-headed arrow. Could you have called it YX? Yeah, you could have. Now, if this question corresponded to the second picture, I could have had multiple answers, because I could have said GH, but I also could have said GF, because even though in the picture there's not a line going through them, because they're 2 points, I can draw a line through them. Same thing with HF. Now, this picture actually corresponds to the question, name a plane that contains 3 non-collinear points. So it's actually a good thing that F is not on the line GH, because now I can name that plane using those 3 letters, which is what I'm going to do. I'm going to call it plane GHF. Now, if you remember from algebra, there was a unit about systems of equations. That was where you had 2, y equals x equations, 2 variable equations, and you determined using either substitution or elimination algebraically what x and y values made both of those equations true. Now, hopefully you also spend some time looking at how to solve it graphically, and you realize that if it was 2 linear equations, typically because they could have been parallel, but most of the time they would intersect at exactly 1 point. So that's actually where these 2 other postulates come from. 1-1-4 says if 2 lines intersect, then they intersect at exactly 1 point. If they're lines that are straight and go infinitely in 2 different directions, there's no way once they intersect at an exact point that they will ever intersect again. Now the next postulate, 1-1-5, says if 2 planes intersect, they're going to intersect at a line. So, that first postulate says 2 lines intersect at a point. This next one says 2 planes intersect on a line. And I'm going to try to draw that for you guys. I'm not the best artist, but if I have this plane, let's just call it R, because that's what we've been calling it. And that plane is 2-dimensional, kind of going up and down. And then I have another plane that's 2-dimensional, but this time it's going more left and right. Then if I want to show their intersection, they actually intersect at this little dotted line right here. So this little dotted line from this point to this point is the intersection. Seeing as because both of these planes are two-dimensional, when they intersect, their intersection is not going to be one point, but a collection of points. In other words, a line. So now we have a few more example problems. So this first one just says sketch two lines intersecting at exactly one point. That's pretty easy. Really, we just got to sketch two lines that intersect. And as soon as you draw that, you should notice they should only intersect at one exact point. Now, if we want to be like technical, we should actually like name all this stuff. So I'm just going to say this is A, this is B, this is C, this is D, and the point where they all intersect, I'm going to call E. So I can say line AB and line CD intersect at point E. The next example says sketch a figure that shows a line that lies in a plane. Again, pretty simple. I want a line on a plane, so I just draw a plane. And again, planes don't technically have to be have four sides, but that's just the way most people like to draw them. And because it's a plane, I'm going to use 3 points so I can name it. I'm going to use points A, B, and C just to keep it simple. So A, B, C. And if I want to draw a line that lies on that plane, well, if A, B, and C already lie on the plane, and I know through any 2 points there's a line, I can just draw a line that goes through any 2 points. I missed A a little bit, but pretend I didn't. So now I have line AC that lies in plane ABC. Now the last question here says sketch a figure that shows 2 lines that intersect in 1 point in a plane, but only one of the lines lies in the plane. Now this is a difficult one. So first of all, I have to have a plane. I'm going to draw my plane. I'm going to call it, again, I'm just going to use simple stuff. I'm going to call it, A, B, C. And I want 2 lines to intersect at exactly 1 point, but only one of the lines to be in the plane. So I'm going to make BC a line that's in the plane, because again, if the points are on the plane, then the line has to be in the plane. And I'm actually going to draw a line that also goes through B, but is not on the plane. And the way I'm going to do that, actually it would probably be easier to use C, so I'm going to use C. The way I'm going to do that is I'm actually going to draw this little dotted line that goes down there, and it goes up. Think of a piece of paper, and you like pushing a pencil through the paper to rip through the paper. That's kind of what's happening here. I'm drawing. I'm taking my pencil, which I'm going to call, line E, C, and I'm pushing it through at point C, and the piece of the line from C to E is behind the paper, and after point C is in front of the paper. Now, this whole dotted line business, it does pop up, so make sure you're paying close attention to that. If you see a picture of a plane and you see some sort of dotted line through that plane, you need to realize that means that line is not actually on the plane, but instead it's going through the plane. All right, here's some lesson review questions. I would say it would be a good idea to pause the video, try these, and then come back to the video. I mean, you could just not pause and I can go over it all for you, but that's not really helping you to make sure that you know what you just learned from this lesson. So you might want to pause, make sure you know what you're doing, or make sure for the most part you know what you're doing, then come back and just check your answers. So right now would be a good time to pause. All right, hopefully you paused it and you got some answers and you want to check them. The first question says, tell me two opposite rays. Now, when we're talking about opposite rays, remember, basically two opposite rays just form a line, but in order for us to name two opposite rays, that line has to have at least 3 points. When I look at this picture, there's only one line that has 3 points. That's BCD, or just, line BD or line BC. So the point that is in the middle of B and D is point C. So both of my rays are going to have to come from point C. So my two opposite rays here are going to be CB with a one-sided arrow and CD with a one-sided arrow. Now the next question says, all right, well, let's look at ray BC. So now C is no longer my endpoint. Now we're looking at just ray from B to C and name a point that's on BC. Well, you can name B or you can name C. Those are both points that are on the ray, but I think the question really wants you to call out that D is also on ray BC. So I'm gonna say point D. The next question, 3, says, what's the intersection of plane N and plane T? Now remember, the intersection of two planes is a line. So what I'm going to do is I'm going to look at both plane N and plane T and figure out what points lie on both of them. And I need multiple points because I need there to be a line. Now if I look at plane N, which is going up and down, I have points A, C, D, and A are all on plane N. Whereas if I look at plane T, which is kind of going, it's hard to look at this in a picture, but it's kind of coming towards us and away from us. That plane has points B, C, D, and this little point E over here. That point E is not on plane N, and this point A is not on plane T. So the points that are on both of them seem to be B, C, and D, which are all collinear, which means I can really just name that exact line really using any 3 of those points. So I am going to say, I'm just going to call it BD, line BD, and it's a line, so we need the double arrowhead. Then the last question here says, point out a plane containing E, D, and B. And like we just said, that point E is only on plane T. So I'm just going to say plane T. Now, again, did you have to call it plane T? No, you can name a plane using 3 points as well. So I could have, this question said, name a plane containing E, D, and B. I could have just said plane EDB because that's what they wanted. They wanted a plane that contains those points. So if I just named it using those points, that I would automatically be correct. Now, hopefully you also tried these last 2. If not, you could pause and try them out. But these last 2 ask us to draw. The first one says, draw a line intersecting a plane at one point. So again, it's a little more complex, but I obviously need a plane. So I'm going to draw a plane first. And they want a line that intersects the plane at exactly one point. So I am going to draw one point. I'm going to name it. I'm going to name it point A. And because it's a plane, I should really draw other points. So I'm just going to draw a point B and a point C as well. But I want a line that doesn't go through 2 points on the plane, only goes through 1 point on the plane. So again, this is where our dotted line comes in handy. Because again, that dotted line represents that this line is hitting, it's going through the plane. And then I can draw this point going up. And because it's a line, I'm going to put another point on here, call it point E. So now I can say line AE intersects plane BAC at point A. And then number 6 says a ray with endpoint P that passes through Q. So this is very similar to the one we did on the other slide, where if it's a ray with endpoint P that passes through Q, that's really just saying draw ray PQ. I'm going to start at P, and I'm going to go infinitely towards Q. And there you have it. That was lesson 1 1 points, lines, planes of geometry. I know the video was long, but I hope it wasn't difficult. Again, these are all definitions that you are going to use very often in geometry, so make sure that these definitions make sense for you. You don't have to know the definitions verbatim based on what I said. You just need to understand what these things are. Okay, have a great day.